This lecture continues the topic of functions. I will show that using functions in Bash is generally very similar to using functions in other programming languages. Let's start with showing a recurrent function, a function that calls itself with a bit modified set of parameters. In opposite to examples used often in other languages that present some kind of mathematical expressions like factor or Fibonacci sequence, we will work with directories and subdirectories. That's a better example for a system administrator. This could be useful, for example, when we would need to perform some actions on selected files in a directory and its subdirectories, like compressing them or encrypting. In a moment, I will write a function named displayDir that should traverse recursively a directory and all its subdirectories. I will start from the end, so that's how the function will be called. I will pass as argument the directory, home, root, but that could be also any other directory on the system. As usually, following the syntax, I'm defining the function displayDir. And now, the first problem. The function could be called recursively. That could cause that the variable's values of the first call of the function would be overwritten by the values modified by the following executions of the same function. Well, we can easily avoid that risk by defining the variable as local. The local variable dir file will point to the initial directory passed to this function as an argument. So, now in our case, when the function is executed, the dir file variable will have value of the home root. And now the key section of the function. If the passed argument points to a file, so if the test-f dir file returns 0, we will display a message showing the name of the file. But that could be so that passed to the function argument points to a directory. In such case, first I will display the name of the directory and next I will list that subdirectory. And for every file or directory that would be found here, I will call once again the function displayDir. That's the most important part of that lesson. Recursive call to the function. displayDir calls displayDir, but the argument is a bit different. This ends the conditional statement and we can perform the first test. Calling the script, I will direct the output to more because I expect to see here many directories, subdirectories and files. What we have? A directory home root. In this directory we have found a few files, but we have found here also a subdirectory named finbook. In this directory we see again few files. Returning to the parent directory, we have again two more files. And now, subdirectory named forLoop. In this subdirectory, we have another subdirectory named files. And this subdirectory has following couple of files, and so on. So the function calls again and again itself. The call was recursive, so maybe a bit complicated, but I think that's something what could be used by a system administrator. As usually, we can now change a bit the function, adding an expanded functionality, and by the way, understanding a bit better how it works. One of the new features could be that the child directories and files should be indented. That's why it would be handy to have a numeric variable allowing to remember the nesting level of the function. If the function is deeper nested, it should produce more indented messages. At the beginning, the nest level is equal to 0. The function must somehow remember the new argument that we are sending to it. I will create a local variable level and I will assign to it the value $2. Time to create the indentation. So before displaying anything, I will first display some dots. How many? So many as the level value. Let's use the opportunity to show how to work with an alternative for syntax. Using it, we can easily execute a specified activity a given number of times. In our case, the control variable n is equal to 0, and in every iteration, n is incremented by 1. The loop will end when the control condition is false, so when not true, that n is smaller than level. This syntax is often used in other programming languages, so if you know them, use your experience. In Bash, we usually use the other version of for shown already in the previous lessons. In the loop, I want to print a dot and space without jumping to the new line. That's why I need to use the option -n. Finally, we will produce here so much dots as defined in the level. We need also modify the line where the function is called recursively. We will need to step into the deeper level, so the value of level must be increased. The new value of level will be level plus 1. The new value will be next passed to the recursive call of the function. Now, when I call the script, I can easily see to which catalog a file or a subdirectory belongs. There is a main directory, home Vavel root. In this directory there are few files, and a subdirectory, fin book. Here we have again 2 files. Next, the content of the fin book ends, and we are back in the parent directory. Here again we have 2 files and a directory. Next, we have a subdirectory and a subdirectory of that directory, and some files located there. That's the third level, third dot. In this lesson, we have shown that a function in Bash can work like functions in other programming languages. One of the similarities is that the created here functions can be executed recursively. Bash works mostly on operating system level, on files, directories, users, services, and so on, while when using other languages, most probably the problem will be more business related. I think that's the one of the biggest differences between Bash and other languages. Another nice feature of functions in Bash is the idea of putting multiple functions in one file, a library, and this will be the topic of the next lesson.